if we look at quadratics are very much the same thing. I have my main parent graph here of y equals x squared. So I'm just squaring everything. At negative 4 squared is 16. Negative 3 squared is 9. That is a 9. Negative 2 squared is 4. And then I get 1, 0, 4. Oops, sorry, 1. Jumping ahead. 2 squared is 4. 3 squared is 9. 4 squared is 16. And then I'm going to graph those particular points on my graph over here. So at negative 4, actually I'm going to start at 0 because that makes it a little easier. At 0 I go up 1. Negative 2 I go up 4. Remember, it's symmetrical, so if you want, you can be graphing them on both points. We've graphed this graph a lot. If I go to negative 3, I go up 9. And I'm just going to do both sides again, and then I can go up to 16. And then I'm just going to connect my points. So this is my parent graph. I'm going to label it. Then we'll switch colors for the other one. So it's same as what I did before, is I am going to be referring to my parent graph. So I'm going to be looking at these numbers here, and I'm going to multiply them by this number here. In this case, it's a half. So I'm going to multiply by a half or divide by 2. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 1 divided by 2 is 0.5. 0 divided by 2 is still 0. 1 divided by 2 is 0.5. 2 divided by, or 4 divided by 2 is 1. 9 divided by 2 is 4.5. 16 divided by 2 is 8. And I think I made a mistake on that because that one does look a lot like a 9. And that's really supposed to be an 8 over there. We'll try to write it in better as a 9. So that one should also have been 4.5 because our original number was a 9. Those are the numbers that I now graph. So I'm going to go to, I start at the 0, 0. It's, when you first start, it's kind of hard. Those numbers get really squished. Negative 2, I'm going to go up 2. So we can kind of start to see already that it's wider. And negative 3, I go up 4.5. And at negative 4, I go up 8. And if I kept going, my graph would still end up being wider than my other graph. So that's y equals 1/2 x squared. My last one then is I'm multiplying by 2. So I'm going to go back to my parent graph and I'm going to multiply all those numbers by 2, and hopefully you'll start to see right away that it goes up faster. So 16 times 2 gives me 32. 9 times 2 is 18. And 4 times 2 is 8. 1 times 2 is 2. And 0, and then I just keep going. 2, 8, 18, 32. And then I'm going to graph those points. So again, I start at 0. And if I move over 1, I'm now up 2. It's kind of a skinny little thing in there. If I move over 2, I go up 8. And then I go up 18 when I go up to 3. And then I can connect my points. I'll label that by just drawing that color in. Y equals 2x squared. Running out of room on that side. So these change that initial shape of the graph. My out and up chart, when I'm using those, again, the first 2 columns are my parents. So the ones that we have been graphing forever. My equation says that I'm multiplying by 2, so this last column I'm going to put in by 2. You can make a new equation here. Actually, let's change that to a 3. Just to give us something different. And again, it would be something like x plus 1 squared, and we can even do a minus 4. We can have that whole equation, but because we have a 3 here, that's the only thing that's going to change in how I'm graphing it. I would find my vertex, and we'll do those in just a little bit. So this time, remember, you are multiplying this column by the 3. So I'm going to take 1 times 3 to equal 3. 4 times 3. And on this one, I think you should write it in kind of what I'm doing here, just to remind yourself what column you are multiplying by. 9 times 3 equals 27. I'm not even going to do that last one because I know I'm never going to get something with 27. When you're graphing, this column is gone. I now, from my vertex, will graph this out and this equation here. So we're going to go do a couple examples on your sheet, but I want you to be able to see how you do these. The first thing that I'm going to do is what I would normally do with my graphs, is I'm going to look and I'm going to say that this part here is going to move right 3 and up 1. So I can go ahead and I can put my vertex on my graph. So from 0, 0, I go right 3 and up 1, and I'm going to put a dot. The next thing I'm going to do is I'm going to use my out and up chart. So I have a quadratic. So I know I have 1, 2, 3, 4, and that this is going to be 1, 4, 9, 16. And I know that because that's what happens whenever I have this squared in that graph, that quadratic parent. This is that out and up chart. So now I'm adding in my last column, and because of this 2 here, I'm going to multiply by 2. So I multiply my up column by 2. So I get 2, 8, 18, and 32. When I go to graph, that column's gone because I'm not using that particular column for anything other than generating those last column numbers. So from my graph, then I am going to graph that out and up. So from my vertex, I go out 1, up 2. From my vertex, I go out 2, up 8. Up 8 isn't on here, but I'm just going to kind of guesstimate where those are. And I'm going to draw in my graph. So finding my vertex is normal. There was no negative sign out front, so I didn't have to worry about it flipping. And my graph should be narrower than what my parent graph is, or what my parent graph would be if it was graphed there. So I'm going to try one more here, this particular kind. So on this one here, we are moving left 1 and down 4. And I'm getting that just from where I normally would. We have that little negative sign here, so that means it's flipped. So instead of an up, this should be down. And then I'm going to start 1, 2, 3, 4. I have a absolute value equation. So I'm going to use that absolute value equation chart, 1, 2, 3, 4. And I'm going to go ahead and I'm going to put in my vertex. So my vertex is left 1, down 4. So here's my vertex of my graph. I am multiplying by 1/2. And I already know it's flipped, so I know my graph is going to be opening somewhere this way. I'm going to take everything that I have in this middle column and multiply it by 1/2. So 0.5, 1, 1.5, and 2. And then I go ahead and graph those by crossing off this middle column. And I'm going to graph my out and my last one, which is my new down column. So from here, out 1, up 0.5, out 2, up 1, out 3, up 1.5, out 4, up 2. And I can kind of see what my pattern looks like on these, so I'm just going to continue. That's the nice part about absolute value. It's almost like it's a slope. And if you look at this 1/2 here, it's the same as a slope. So if I pick a point on my graph that lands nicely on those grid lines, it is like up 1 over 2. So I do have that slope aspect that can help out with the absolute value. It does not work for quadratics. And then my graph is done. I've graphed an equation, and that's as difficult as they're going to get. Equations is very similar to this. First thing I want to do is I want to look at the shape of the graph. So I have a U shape, which is telling me that I have a quadratic. So since I have a quadratic, my out and up chart is going to be that of a quadratic. So 1, 2, 3, 4 for my out. My up is going to be 1, 4, 9, 16. And this time what I'm going to do is I'm going to actually look at my graph and see where my points are. So from my vertex, I go out 1 and I go up a decimal. And if you can't tell, just leave that blank for now. So then I'm going to look at the next point. I want to look where there's an actual point on my graph, which happens to be right here. If I go out 2, I get to that point. So that's going to be out 2, up 2. So I want to put it where I had that out 2. Again, let me just show you why I did that. So I'm looking for a point that lands nicely on a grid, out 2, up 2. And that's just because I can kind of look at this point here and it looks like it might be a half, it might be a third, but if I take those whole points, it's going to be easier to see. And then I can look at the next one. It looks like it's 4.5. To verify, I'm just going to use this one that's out here. So if I go out 4, I can count. It's 1, 2, 3, 4, 5, 6, 7, 8, up 8. So from those, I can actually see what I multiplied by. I need to see what did I multiply 4 by to get 2, and I multiply by 0.5 or 1/2, kind of however you choose to do that, and so that I can look and say, yeah, that was definitely a 0.5, this was a 4.5. Again, we're looking at 1/2, 1/3, 1/4 are the main things we're going to be using. So writing my equation, it's not flipped, so there's no negative sign. The 1/2 then goes out first. It's quadratic, so my parentheses with a squared, and I move to the left 3 spaces. Moving to the left, I add in there. I move down 1, 2, 3, 4, 5 spaces, and moving down is a negative. So this is my equation for that graph. This 1/2 is the new piece. Everything else, this is all the same as normal. If you can't get that 1/2, everything else is the same. And again, we get that 1/2 through our out and our up charts. One more equation we're going to look at that we're going to come up with our equation for. So I can look, it's a V. That means it's an absolute value chart. So when I'm writing my out and up charts, 1, 2, 3, 4, 1, 2, 3, 4, and then Right, so from here, I'm going to look at from my vertex. If I go out, my first point on the graph is here, and I can see it maybe a little bit better here where there's that actual dot, and your graphs will be hand-drawn so that you can see those. So if I go from my vertex, out 1, up 3, so my last column, I'm going to put in here that I had to go up 3. Then I look for my vertex. If I go out 2 to where it meets with my graph, I actually went 1, 2, 3, 4, 5, 6, up 6. And I can keep going on these. From my vertex, I go out 3, and I'm going up to this point on my graph, and I can count those. And that would be going up 9. And again, from my vertex, if I went out 4, and I can count how far up I went on my graph, and that should be 12. And so I look at the relationship. What do I have to multiply this column by to get this column? And you might figure it out before you get to all your numbers. And I need to multiply by 3. So that's the part that's going to go up in that top piece. And that's the part now that's part of my equation. Y equals, it's not flipped. If it was flipped, the negative would be first. 3. It's an absolute value equation. And I move to the right, and I move to the right 3. So minus 3. That is not changed from what we've done before. And I move down, and I move down 1, 2, 3, 4, 5, 6, 7. So here's my equation. Again, that 3 is the new piece. Everything else is the same, and the same as what you've done before. So you have more question or more sheets that I want you to work on. If you need to, your substitute has those sheets, and she can help you out with at least looking at the answers and ask your friends and neighbors if you get stuck. Good luck.